What would it take to control the weather? Weather is one of humanity's greatest challenges. It can destroy homes, the food chain, and even entire towns. Since the dawn of mankind, we have been casualties to its indifferent whims, trying to stay one step ahead of disaster. Fortunately, we do possess quite a bit more knowledge than our ancestors, and could, in theory, have more of a say in what happens. So what would be involved with acquiring those tools? And how far could we take it? I'm actually Christine, and here's how it works. Weather and climate are two terms often mistaken for the same thing. Weather is the state of the atmosphere in a specific place and time. Things like wind speed or whether or not it's going to rain tomorrow. Climate is the long-term version of that. So the average temperature of the Indian Ocean over the last 30 years, or the frequency of nor'easters in New England since 1980. Humans can certainly affect the climate because it's about contributing to that incremental change over time, like emitting fossil fuels that warm the atmosphere. Changing the climate in this regard is easier because it's about behavioral modifications and chiseling away at the problem over the years, rather than trying to stop next weekend's forecast. This video is about weather, so our ability to control a specific dramatic event like a hurricane, and that is much more difficult. Controlling the weather is pretty much on the same technological level as terraforming a planet. To better understand the challenge, you first need to appreciate the scale we're dealing with. Terraforming is the process of transforming a planet into Earth-like conditions. For Mars, that means increasing the temperature and atmospheric pressure, adding water, oxygen, and countless other factors to make it habitable. Terraforming is a very common element in science fiction because how else could you have the characters explore a new world without suffocating? In Star Wars, for example, most of the planets can support life. People bounce around from Tatooine to Coruscant like it's nothing. It's never explicitly stated in the main trilogies, but in order for those planets to be habitable, an ancient civilization like a million years prior would have had to terraform every single one of them individually. Terraforming is theoretical, so no one is sure how it would be done or how long it would take. Much of it would depend on the existing conditions of whatever planet you're considering. In 2015, Elon Musk proposed detonating nuclear bombs over the north and south poles of Mars. The idea being that the explosion would vaporize the existing ice, freeing up whatever water is there and enriching the atmosphere, essentially warming the planet. This is a brute force version of terraforming rather than surgical precision. The explosions would certainly heat the area and water would be released, but the atmosphere is so thin that it may not be able to retain the new influx of water for long. And even if it did, Mars has no real protection from solar radiation like Earth because it doesn't have a global magnetic field, meaning that whatever new atmosphere is created will eventually be incinerated, bringing us right back to where we started. Mars, quite frankly, doesn't have enough raw materials to work with. We would need to bring in those outside elements like oxygen and nitrogen to increase the atmospheric volume, all of which would weigh billions upon billions of tons at least, not to mention jump-starting the core or whatever to create a magnetic field to protect whatever we do manage to produce. But there's probably not enough molten material in there to work with anyway. So yeah, we could try it, but it won't be successful outside of providing us with some pretty interesting data. One advantage is that running experiments on Mars, though barbaric and global, is easier in a few ways. We could blast a bunch of nukes and it wouldn't hurt us. We wouldn't feel the nuclear fallout. And if it doesn't work, who cares? Nothing lives there anyway. Probably. So we can perform all sorts of extreme experiments there. Earth is a bit different because we live here, and we can't just set off a nuke because a billionaire wants to go skiing this weekend. But the task is similar in that controlling the weather is a type of terraforming. It's making a place more hospitable by controlling the elements on a global scale. Because weather is not as isolated as you think. The temperature in your town right now is due to conditions over the ocean, on the other side of the country, or even from space. So true control would require an infrastructure to manage the entire planet under one program. To control the weather, we'd have to start by knowing all of the variables. That means a more complex global satellite system, high altitude balloons or drones, international agreements that include comprehensive data sharing, and sensors in the ocean pretty much every few miles. We're talking about so many sensors in so many places because you're dealing with a dynamic system. That has to be monitored on a three-dimensional scale in real time. It's not enough to know the temperature outside your door is 20 degrees. You would have to know every point along the entire atmosphere atmospheric column above your head too. I mean, if you're looking at a map and it says the humidity is 67%, at what altitude? Even the bottom of a mountain has a different temperature from the top, and that's the same spot, so to speak. So you have to include all of those factors. Then we have to decide, is this a micro scale or a macro scale? Are we trying to control the weather for a city or an entire nation? Cooling a city by flipping a bunch of mirrors so that the top of buildings are reflective, or blowing hot fans to disperse fog at an airport is manageable. But that's not what people think of. When you're talking about controlling the weather, at least in localized regions, the first thing people think of is cloud seeding. Cloud seeding is a type of weather influence that tries to create rain by releasing a seeding agent, usually silver iodide, into the sky. It only works under very specific circumstances, but some places, like the Idaho Water Resource Board, are already doing it. For it to work, a lot of things have to go right. For starters, there needs to be clouds already. If it's a sunny day, it's too late. You need something to start with. Clouds are made of water vapor, water droplets, and ice particles. Gas, liquid, solid. As they collide and grow, they get big enough to fall, and you have rain or snow. To get a seeding agent into the air to encourage that, it can be burned and released like smoke or dropped from an aircraft. Silver iodide is a popular choice because it has a similar shape to ice, so it acts as kind of a landing pad for other molecules to collect in the clouds, and once they grow big enough, they fall. The effectiveness of cloud seeding differs from spot to spot, and some people question if it's really doing anything at all. There are reports from Nevada, Wyoming, and Australia that have seen an increase in precipitation over time. But even in those places, it's estimated that less than 10% of the total water budget in that area's sky is impacted by cloud seeding. So if we're talking about controlling the weather with the same absolute jurisdiction of a thermostat, current cloud seeding methods aren't cutting it. Twisters, which is a movie that came out in 2024, had an interesting take. The movie was about a young scientist who tries to tame a tornado by blasting various chemicals at it. The first of which is silver iodide, which, as you now know, helps moisture turn to rain. Then they take a truck and drive into a tornado and release about a dozen barrels of sodium polyacrylate, which is a real polymer, meaning that it's very absorbent. So it's supposed to pull all that moisture out to cool the whole system down, basically blocking the inflow and choking the tornado. There are a few problems with this. For starters, it isn't enough chemicals. You'd need probably at least 30 tons, depending on the size of the tornado, which would require a Mack truck. Secondly, it would take roughly 15 to 20 minutes for it all to be absorbed and spread out enough to have an effect. And when the average tornado only lasts about 5 to 10 minutes on the ground, what's the point? And third, all of that air, wind, and energy has to go somewhere. It doesn't just disappear. So taming this tornado could mean starting another set of storms downstream. Predicting those outcomes would require an obscene amount of data collection or a breakthrough in mathematics, something like chaos theory, which is a branch of mathematics that studies dynamic systems. Solving that could be the equivalent of predicting the future. But that's too much to dive in here. I have another video on it if you want to learn more about chaos theory. So, while on a micro scale, influencing the weather is within technological proximity, macro scale is not. That would be things like hurricanes and monsoons. But we have nukes, right? Why can't we just drop a bomb? For one, nuclear fallout and radiation isn't fun for anyone, but also a hurricane releases far more energy than a nuclear explosion, so it wouldn't have enough of an impact anyway. For reference, most of our power grid is fueled by fossil fuels. Next is renewables, things like water, solar, hydropower, and then you have nuclear power plants, which have a significantly higher energy density than fossil fuels. Nuclear is the upper limit of what humanity can harness. So yes, we have nuclear weapons. We can end the world, surely we can manage it, but being able to destroy a thing is not the same as controlling it, as we've learned throughout history. But even if we could disperse a storm through brute force, it doesn't mean you'd be able to steer it. For one, we have very little say in what happens after a bomb is detonated, and secondly, it's the same reason why we can't perfectly forecast the weather. There are a range of potential outcomes because there are so many moving parts. We take chunks of data and make forecasts based on overall averages with impartial initial conditions. Basically, we don't have the technology to track every single molecule in the air and sea, which brings us to the same problem that they faced in Twisters. We can't predict where all of that energy will go. The sledgehammer approach to terraform Mars would be trial and error. But if we're talking about a fragile planet with 8 billion people, it requires surgical precision. We need a comically massive data infrastructure, international agreements, and the power of the sun. Earth is not an isolated machine running off its own fumes. Actually, our weather doesn't come from us. It's driven by the sun. That's why we have winter and summer, which is based on how much sunlight one part of the world gets over a few months. At night, when one side of the planet is in the dark, there is an uneven distribution of solar energy. And this creates wind because the high pressure systems are rushing to the low pressure systems. There are other factors like Earth's rotation, the Coriolis effect, mountains, ocean currents, the moon, and volcanic eruptions. But it comes down to the sun. If it wasn't there, that's game over, regardless of whatever feeble attempts we make. The sun is the energy source. Fortunately, it's in the middle of its roughly 10 billion year lifespan, so it's in the stable part of its life. This means we can expect a consistent release of energy even through its own seasonal periods. Controlling the sun is out of the question. If we had the technology to do that, we'd have cities on Mars and people would be sending their kids to boarding school on Venus. Because the technology to do those things would pale in comparison to whatever Lovecraftian apparatus it would take to manhandle a star. The best we can do is control what happens once that solar energy reaches us and creates the conditions we experience. Things like wind, pressure, moisture, and heat, all of which would need to be individually altered. Starting with the wind, it is the movement of air. It's caused by pressure differences due to the sun, and those systems can be thousands of miles long. A high pressure system means that the air column above that area basically has more particles. A low pressure system is thinner. That's why high goes to low. Just like if you had a cup of water connected to an empty cup, water will rush from high to low. And the bigger the pressure difference, the faster it moves. To control wind, you'd have to control pressure systems and balance them, so there is no difference. That means either you manually transfer molecules from high to low systems and consequently create winds hundreds of miles per hour, or somehow you remove them from the entire system and, I don't know, put them in a box and release them slowly over time. Controlling moisture on a micro scale is possible. This would be things like cloud seeding or dispersing fog, but for a macro scale, you'd have to tackle the ocean because this is a water planet and that is the source of our moisture. Shifting its temperature to reduce or increase evaporation that fuels storms, again, requires energy levels we don't have. If we could flip a switch and change the temperature like that, Earth would be a very different place. It'd be global mist. We could run some of these terraforming tests on Mars and see what happens, but even if they were successful, Earth is twice the width of Mars. So we'd need even more resources and energy to pull off the same results. That's another main problem here, energy. Whether we're talking about manipulating wind, moisture, or heat, we would need to run Earth like a machine. And while theoretically possible, the math and science to hash it out isn't there yet. Sure, we could try microwaves, lasers, shade structures, or even a bomb, but those are small scale attempts that don't match the level required to modify an entire planet so that the whole thing runs like a machine. If we had that technology, we would be an interstellar species. It would be equal to or greater than the power of the sun, and we could terraform other planets and do there what we did here. It would be the beginning of human expansion into the cosmos.